Okay, so last time, so we had this example. So we'll just continue our discussion on this. So what was our z computed? Okay, I'll just. So is my slides? Are the slides? Can you see the slides from your end?
Yes, sir.
Okay. So let's have a. So let's continue this. So what was our z computed? Just a review. So our z computed was it was 39.6 minus 35.4 minus, since we are talking about just the difference, so it does not say whether it's greater or less than. So our hypothesized mean is just the hypothesized mean difference is just 0. Okay? So divided by square root of. So the formula is always over n. So this is included, the n is included, okay? So we just need to, okay, I'll just put here the formula for now, okay? Which is just actually, just put this, um, 6.3 squared plus 5.8 square over 35 over 35. Okay, so what is now our z computed? So we have 4.2, the numerator. And you can also help me compute, no? If you want to. I forgot. It should have been square root. Yes, that's correct formula. Okay. Plus 5.8 square divided by 35. And we get the square root. So we have 1.447. Okay, approximately equals 4.2 divided by the answer. Okay, which is 2.90. Okay, so this is now our z computed. So how do we actually know from the z computed whether the um, hypothesis, the null hypothesis should be rejected or not? So remember that the hypothesis testing here actually refers to what we call the null hypothesis testing. Hypothesis Testing. Yes. Why is it called null? It's because it's like in the court of man, no? So in the court of man, we always assume that a person is innocent until proven otherwise or until proven guilty. So we always assume that the difference here is zero. So there is no difference. And we always use the distribution with mean zero as the so the null is it means that the distribution of values follows the normal distribution and the mean is zero. Now if we have a data, so we get the data, so we collected the data and then we try to compute the z. So what can we expect for z if we assume a null hypothesis testing? A null hypothesis. So we know that if we get a sample, it's expected that we will not get a sample that's exactly zero mean because there is what we call the sampling error, okay? It's because we do not know exactly what the population or we don't have the population, so we only get the sample. And if we compute the difference, there is no, it's expected that we can compute a difference that is different from zero. But the question is the difference from zero great enough? Okay, is it large or small enough that we can say that this sample did not come from this distribution, from the null distribution? Is it too large? Because if we say that we computed the mean somewhere here, so the difference is not too large to say that it's really different or it's actually different. It's not too large. The difference is just due to some sampling error. So that's the idea. So if we can compute a value, let us say, somewhere here, then that's already too far away that we can no longer ignore the difference between the zero and the computed value. It's more of like this. For example, for the population, the mean is, let us say, for the actual population, the mean is, let us say it's around 40, okay? And then we collected sample and we get a mean difference of around 40.2. So is 40.2, is the difference between 40.2 and 40 big enough to say that the sample came from a different population or not? So we're actually trying to determine whether 0.2 is big enough to conclude that the mean is not actually 40 in this case. Okay? So naging zero lang yan siya because we made the transformation. Okay? So that's actually the question that we're trying to answer. Now, using this, can we say that 4.2 is big enough to say that it is different from zero? That's the question. So what we do is we actually, paano kaya ito i-erase, no? We kaya ito i-erase. Ay, meron. Ay, salamat. Okay. So, is 4.2 markedly different from zero to say that to say that the difference is not really zero? Okay. So that's the thing that we're trying to answer. So we have now here, if this is the null distribution and this is zero, and let us say that 2.2 is 2.9, somewhere here, then there are two options, no? As was discussed last time. We can either compute what we call the Z critical. So sorry ngayon na kasi hindi pa ako nakapili ng stylus. Mahirap kasi maghanap ng stylus. Last time pumunta ako sa mall, wala silang mabentang stylus. Siguro baka mag-Shopee na ako. First time ko pa naman mag-Shopee. Okay, so two options here. So we either compute the Z critical or we compute what we call the p-value. May nag-chat ba dyan? Yes. So, we can either compute Z critical or the p-value. So the Z critical is very simple, no? You have the, hindi na ako ma-perfect ng kuan ba? Uy, graph. Yan. Medyo balance na. So, you just find the value that corresponds, since this is a two-tailed, so the area here must be, and our alpha is 0.05, so the area here must be 0.025. And the area here, on the left, must also be 0.025. So that when you add both of these, it will get you the alpha, which is 0.05. So when you try to compute the Z critical, you just find the Z value here, such that the area here is 0.25. And we know that if we find the Z critical here, this is the same Z critical here. Okay? Same lang siya na Z critical here. Negative lang siya because the normal distribution is symmetric. Symmetric pala, hindi Z kasi Z is iba pala, hindi palang word na symmetric, but it's symmetric. Okay? So ano yung area dito na para masabi natin siya na ano yung Z natin dito such that the area here is 0.025. Okay, so let's go to table, no? We will use the table from Blumen. Okay? Stop share ko muna. Hanapin ko muna si Blumen. Patay na kaya yan si Blumen o buhay pa yan? I think buhay pa naman siya, no? Pero ang alam ko kasi sila ito, patay na. Namaya, ay hindi pala. Namayapa na yan sila ito. Pero ito si Blumen, buhay pa pa yan. Buhay pa pala yan niya. Yan. Buhay pa siya. Buhay pa sana siya. Okay, start muna natin. Tingin tayo na table. Hirap talaga itong ano. Indices. So, ipapakita, share screen ko tong table ko ngayon. Okay, okay na ba? Klaro na? Yan? Yan, klaro na. Okay, so kung klaro na, hanapin lang natin yung Z-table. Ito yun siya. Standard. Okay? Other name for Z is standard. Because why is standard? Because that's our reference distribution always. That's why meron tayong mga transformation na ginagawa. Okay. Go to the standard. Ay. Z-table. Normal. Yan. So basically, ito kasi siya, yan yung mga area, di ba? But that area is the area to the left. Okay? So kung ang hinahanap natin na area is dito na side, so therefore, ang gagawin na natin is 1 minus the area here. So since ang hinahanap natin is 0.025, ano yung area na hanapin natin dito sa table? 0.975. Tama? So hanapin lang natin kasi, syempre, pag 0.975 ang area to the left, we know that the area to the right is 0.025. Why? Because the total area of any probability distribution is always 1. Okay? So we have 975. Hanapin natin si 975. Saan siya? Here. 975. So, ano yung Z critical na corresponding? 1.975 96. Okay? So therefore, kung 1.96 siya, so kung 1.96, ang na-compute natin kanina ay, na-compute natin kanina sa 2.9. Okay? So yan yung Z critical. And then, ang na-compute na, ay di pala yan critical. Computed yan. Compute. Z critical is 1.96. Now, the decision, always write the decision. What is the decision? Decision rule. Reject HO if the Z computed absolute value. Okay? Why? Because pwede kasi ang mabaliktad natin yung kanina kasi 39.6 minus 35.4. Pwede kasi na mabaliktad siya. Maging 35.4 minus 39. It doesn't matter. Okay? Kasi nga difference ang hinahanap. So we look for Z computed. So reject HO if Z computed is greater than the Z critical. So the question is the Z computed here greater than the Z critical? The answer, of course, is 2.9. We know that it is greater than 1.96. So therefore, the decision is we need to reject HL. So we cannot say based on the samples or based on the data that we have, we cannot say we have enough evidence to show that there is significant difference in the average time for each group. Yan yung ating magiging conclusion. So that is actually using the Z critical. Now, to compute p-value, actually mas simple siya kasi titingnan mo lang yung area ng 0.902. Okay? So 2.9. Hanapin mo lang yung area ng 2.9. So dito hanapin natin. So 2.92. So ito. Na 0.9982. So alam natin that 0.9982 is the area to the left. So ano yung area to the right ng 2.92? So ma-minus mo lang yan. 1 minus 0.9982. And that is 0.0018. Is 0.0018 less than 0.05? If the answer is yes, then that's the time we can say that it is significant. Right? So yan siya galing yung yung ating kino-compute kanina. Ay yung p-value natin na if p-value is less than this, we have to reject HO and our p-value was 0.18. So therefore, since this is less than 0.05, then we reject HO. Okay? And the decision, of course, is reject HO. And the conclusion is, you have to state it completely. Okay? So the conclusion is, there is a significant difference in the average times each group spends on leisure activity, just to be complete. So to review, you state the null and the alternative hypothesis. You state the decision rule. Okay? You do the computation. So ano yung test na gagamitin? So make sure that it satisfies the assumptions. Yung it should be that the mean is, no, the population standard deviation is known, the sample is greater than 30. If it's not greater than 30, then the distribution must follow a normal distribution. Okay, so that is now our test. Okay, so I think it's your turn now to do some exercises on your own. So let's have this